So we have this box, and it's 5 kilograms, 5.0 kilograms, and it is displaced 10 meters. So we start here, 10 meters. Okay? And then it gives us the coefficient of kinetic friction. So that would be mu sub k is equal to 0.2. Oh, so it's not frictionless. It does have friction. And then it says, what's the work? Okay?
What is me?
That's another Greek letter.
I always see that and I think he's just like writing his name over here, but what is it used for? Yeah, me too.
Okay, so mu is, it's pronounced mu, and it's like, it's kind of like an M. It's a Greek letter. So you guys got to remember, a lot of these Greek letters, just basically what happens is in physics, we're already using M for mass, right? And we're already using K for kinetic energy. So all the letters are used up. So we start to use the Greek letters for different things. Okay, so it's just another variable. So mu sub k, this is the coefficient for kinetic friction. Now this one's an interesting one because it says, what is the work done by the friction force? So this is an interesting question. It's a great conceptual question. There's a force that's applied, right, to move the object. But then there's a frictional force, and these aren't drawn to scale. The frictional force, due to kinetic friction, goes in the opposite direction. Does that make sense? So what we need to remember is, first of all, I drew my picture. So now the next thing I want to do is start to write down some of these things. We know that F sub k is equal to mu sub k times the normal force, which is also, remember that the normal force is equal and opposite to the force due to gravity, which is just m times g. So we could really say that the frictional force, the kinetic friction force, is equal to mu sub k times the mass of the object, which was given to us, times g. And if you guys remember, g is 9.8 meters per second squared. That's the acceleration due to gravity. Can we calculate the frictional force? Absolutely. We would say that the frictional force is equal to 0.20, right? Because that's what our coefficient of frictional force is, kinetic friction. Then the mass of the object, which is 5.0, times the acceleration due to gravity. And I didn't write down the units simply because I'm running out of space, right? But this is in meters per second, right? This is in kilograms, and the coefficient, that's just a number. It doesn't have a unit. So all my units are correct. So now if I multiply this out, I'm going to come back to that. Remember that we said the work done is equal to the force, but in this case, it's going to be mu sub, well, let's just write it out. Force times cosine of theta times the displacement. Now in this case, the magnitude of the force is going to be all of this stuff. Okay? So that would be 0.20 times 5 times 9.8. Now, here's the tricky question. I've got to do cosine of some angle. What's the angle? Well, now to determine the angle, we have to consider the motion of the displacement. I'm going to arbitrarily say that this is the horizontal displacement to the right. But what is the angle between my displacement and my frictional force? Not 0. They're anti-parallel.
180.
180, because I have to go 180 degrees to go this direction. Does that make sense? So we need to plug in cosine of 180 degrees. And then the displacement is still the same, which is 10 meters.
Is that a point 20?
Yeah, it's a point 20. There's a point here. My smart board isn't so smart today. The calibration's off a little bit.
Catch.
So then if I multiply all that out, I get that the work is equal to negative, it should be 98 joules.